Good morning, good afternoon, good evening, everyone. Welcome to this session, Introduction to Edge ML Ops. Thanks for attending. We're thrilled to have you join today. Before we begin, a few housekeeping notes. If you have any questions during the presentation, please feel free to write them up in the chat. We'll be monitoring the chat throughout the session. We will also have a dedicated Q&A segment at the end of the session. And most importantly, if you do not have an account yet on Edge Impulse, please sign up. We will put the link in the chat, or you can go to studio.edgeimpulse.com. This way, you'll be able to create your own Edge AI models and put into practice what you'll learn today. Now, let me introduce you to our speakers for today's session. His name is David Tischler. He's in my team. He's a developer advocate at Edge Impulse. He's helping the community learn about how to shift from the cloud to the edge and how running AI ML workload on tiny devices is now 100% achievable. In his spare time, David loves horsepower and downforce, and he's an extreme recycler. That being said, thanks a lot, David, and the floor is yours.
Thanks, Louis, and who doesn't love horsepower? Hi, everyone. Welcome to Imagine Innovators, the developer conference for Edge AI, which, by the way, is our first ever conference devoted entirely to Edge AI practitioners. If you've been to Imagine in person or watched online in the past, you know that we cover a wide range of topics, from thought leadership and fireside chats to business updates and more. But this time, we're focused solely on the developers and engineers that build Edge AI solutions. As Louis said, I'm David Tischler. I'm on the DevRel team here at Edge Impulse, and welcome to Getting Started with MLOps, tools, techniques, and a tour. I'll walk us through defining MLOps and its role in Edge AI. We'll talk about best practices. I'll take us on a whirlwind tour of some of the options available to help with MLOps, and then we'll finish up with some Q&A. We also have people from the team in chat, so like Louis mentioned, definitely feel free to drop your questions in along the way, and we'll try to get them answered as we go along. I'll start us off, however, with a quick recap of Edge Impulse for those of you who might not already be familiar with the product. Edge Impulse is an easy-to-use web-based platform for building AI models intended to run on edge devices. Developers can use sensor data, audio data, or images to build models that can run on MCUs, CPUs, GPUs, NPUs, and more three-letter acronyms ending in processing unit. It's quick and easy to get started, but also has advanced features and expert modes for data scientists and ML engineers. No matter your skill set, you can come away with optimized and production-ready Edge AI models. Generally speaking, to build an AI model in Edge Impulse, well, really any AI model, you'll go through these 4 phases. But I'll break this out a little bit differently in a moment and expand on this a bit. You'll start off, though, with collecting data. So that could be pictures, audio, or sensor values. And you'll use that data to extract features and build your model. You'll certainly want to test your model to make sure it works, make sure it can detect objects, spot keywords, classify gestures, or whatever it is that you are interested in classifying. And then finally, you'll run that model on your device. The places where we see the most use cases and customer activity are in the industrial and digital health segments. But there's definitely other industries and verticals using Edge AI and Edge Impulse as well. These are just the most common ones. In industrial, we see usage in manufacturing for quality control and defect detection. We see a lot of predictive maintenance projects that make use of anomaly detection. We see developers using Edge AI for counting, tracking, and inventory systems. Oh, and safety equipment, PPE, that's another big one. Over in digital health, we see a lot of momentum in smart rings, smart watches, and other wearables that do motion detection and classification, like exercise and activity tracking, health and vitals, such as sleep, stress, heart rate, gesture recognition. And again, I have worker safety here on the slide. I suppose that could fall under industrial or digital health, really. So now that we understand Edge Impulse a bit better, let's get into MLOps and have a look at how we see the process of MLOps from our perspective. I showed the steps earlier, the phases of what it takes to build an AI model. And the last step was, of course, deployment. I've broken it out a bit differently here, but essentially this is the same. So at the point of deployment, you have your model running on the device, and the device is out in the field. Because remember, we're talking about edge AI here, not data center driven AI. So your model is somewhere out in the world performing a task. But what happens when the conditions change out in the world, or the data that you trained your model on is not the same as what you're seeing now? Lots of models are trained on whatever data the engineer or developer collected on his desk had available. But that's not the same as you're going to find out in the world. Looking at these examples, if you only trained on red apples, well, what happens when all of a sudden green apples are introduced into the system? Or if you do inventory counting and you trained your model on product labeling, like that cherry Coke can there on the left, but then the manufacturer changes the look of the label or the product, all of a sudden your model can suffer from poor accuracy or possibly be completely useless if it had overfit and not generalized well. Even simple things like lighting conditions changing, if a bulb burns out, or making it just a little bit darker in a location. How about unexpected background noise or environmental changes from, let's say, a sudden heat wave? That can skew the results of a pipeline flow rate by increasing the pressure in the pipe due to expansion. There's an infinite number of factors that can influence your readings. So let's come back to those phases I talked about earlier that I said we'd revisit, and let's break them down into even more steps, like steps in a workflow. We can start off on the left with data collection, which we talked about already, but is the process of taking pictures of your desired object, recording the sound you're interested in listening for, or capturing that sensor data, such as motions or health vitals over time that you care about. From there, you can curate those samples into a representative data set, which, by the way, is a whole other topic or knowledge area that you'll want to explore a bit. Then train your model, optimize and test it, and then coming around to the bottom here on this graphic, deploy to your device. But to avoid the problem we were just talking about of a model becoming ineffective, you want to add an additional step that I'll call monitor. And very important is this final arrow that completes the loop and joins back up to data collection. That will most likely require some form of connectivity, such as Wi-Fi, Bluetooth, Ethernet, cellular, LoRa. It'll depend on where the device is located and the power and bandwidth available to you. If it's a device in a factory, well, these probably aren't too much of a concern. But if it's a wearable or a device on, let's say, an oil well 100 miles from the nearest town, well, that might be an issue. So I'm going to require some form of connectivity, at least intermittently, as a baseline requirement for MLOps. which then leads into, I'll say, my definition of MLOps, which is continuous improvement and redeployment of your edge AI model as a result of collecting data from an on-site device in order to supplement your data set with localized and current data. In practice, what that actually means is this. You have a device, it's running inference out in the field, but because you introduced that last step that I called monitoring, you realize that your existing data set is not representative of what you're actually seeing out in the world. This means you either have false positives or missed detections in your inference results. Now, because you have connectivity, what you can do is change the workload that is running on your device. And instead of inference, switch back to data collection and upload mode. Capture that net new data, bring it into Edge Impulse, add it to your data set, maybe even eliminate some of the existing data objects if they truly are no longer relevant, and retrain your model. Then, once the model is built, export it or download it from Edge Impulse and deploy it back out to the device. And then finally, switch back again from data collection mode to running inference. Okay, so now that we have that understanding, let's start our tour. I'm going to go over some, but certainly not all of the options that are available to you. And I'm going to split these into two buckets based upon your target hardware that you're running on, divided up by where your application is running, either CPU or microcontroller-based devices. I realize that the model might ultimately get offloaded to an accelerator like an NPU, but the main application thread will start life either on a CPU core or an MCU core. So ultimately, you either have a full operating system like Windows or Linux, or you have some C++, MicroPython, and RTOS, maybe Zephyr, maybe some combination of all of that. Again, I've pointed out here that we need some form of connectivity for all of the options I'll go through. And Edge Impulse can help with the model creation steps, but how you actually make use of the model and then integrate it into your applications, business processes, alerting, machinery start and stop, emergency cutoff, or whatever your use case is, that part is up to your development team. And then the last bullet point here, the fleet management and distribution, is what we'll dive into now. When a device is on your desk, it's easy to update, but a device that is across the continent or across the globe, it's a whole different issue. So I'll start off with the CPU-based hardware. I tend to think that's a bit easier, but depends on your skill set. Maybe you think the MCU stuff is easier. And remember that as you glance at this list, that these are not all of the options out there. So I'll run through each of these, but you'll want to do your own research and figure out which ones are the best match for your particular device, your application and cloud infrastructure, the experience or knowledge that you and your team have, maybe even how easy it is to purchase for your organization. I'm presenting the options, but I'm not a subject matter expert in each one of these, so you'll need to dive a bit deeper on each of them and figure out which one makes the most sense for you. I'll start us off with Foundries.io. Foundries is a Qualcomm company, so that's also like us, Edge Impulse, a Qualcomm company. Foundries uses a customized Yocto OS, and they have an emphasis on secure boot. Workloads are run in Docker containers, and the underlying OS can be updated as well. You can see here in the screenshot what their dashboard looks like, and kind of get a feel for their overall workflow. The next one on our list was Zadata. Now, Zadata runs on something that they call Eve OS, which is part of the Linux Foundation. It's kind of based upon Alpine Linux. Zadata is interesting in that they support both Docker containers as well as full VMs running on your device. So you have a little bit of flexibility there in your deployment methodology. And they're definitely a complete orchestration platform. So, you can see here on that screenshot, they've got quite a bit of analytics and telemetry as well. Next up is a big one, AWS Greengrass. Now, Greengrass is a Java application. AWS provides basically a binary or an application you download and run it on your device. Once it launches, then easily integrates into other AWS services, S3 buckets, and so on. They have a certified partner hardware program, so they go through vetting to ensure that hardware on their list works. Because it's a binary, it's an installation of that Java applet, it'll run on Linux or Windows, but I wasn't able to find that it does any OS management, only the workload management. So if underlying OS updates are something that you're looking for, you'll need to do a little bit of homework there and see if it does indeed support it. Azure, another big one here from Microsoft. The Azure IoT Core product is a Docker-compatible container runtime. Again, it's an installation onto an existing device. And their methodology is that you build a container, push that to a registry, and then the device will update and grab the container from the container registry. Here again, I didn't see any OS management. It's simply workload distribution. Again, you'll want to do some research, check out their docs, but if underlying OS updates and security is an issue for your devices, then you might want to make sure, just check their documentation. Alson. This one is fairly interesting in that it's focused on the NVIDIA Jetson products. They also build their own custom hardware that connects up to Jetson devices that offers out-of-band management, which means you can connect to the device even if it's not booting or if for some reason your applications are crashing. You can still get to it and watch the boot logs and make sure it comes up and gets online. It does allow for full BSPs, the Jetpack distribution, and OS management as well. You can kind of see from their GUI here how their system is laid out as well. Next on the list, Mender. Mender builds their own Yocto-based OSs or offers a Debian runner. So that gives you some flexibility in using their own slim, cut down Yocto OS or tying in if you already have an OS running on something that's Debian compatible. In the Yocto-based OS, I'm not too sure about the Debian version. You'll have to do some research there, but at least I do know that in the Yocto-based version, they do offer A and B partitioning, which is really convenient because you can do automatic rollbacks in case of a failed update. So if you push out an entirely new OS sitting in a new partition, and for some reason it does not boot, you can always fall back to your previous known good configuration. Workloads themselves can be based on artifact files, that's Docker Compose or Kubernetes, if you're only doing application updates. And that's it for the CPU options. Again, there are more out there, but that's what we've got here on today's list. And then we'll move into some of the MCU options. Now, as I said earlier, I find these a bit more difficult. If this is your area of expertise, feel free to let us know, but I don't have as many choices here on this list. I'll start off though with Goliath. And Goliath has Zephyr, Nordic NRF Connect SDK, ESP, IDF, Modbus Toolbox from Infineon, and FreeRTOS support. They also have a brand new Bluetooth to cloud connectivity option, and they support fleet management, data routing, and OTA features to update your MCU class devices. Atom. Atom is a brand new one that I just came across, and it's built on the open source project Ochre, which is another Linux Foundation project. And they are all about building WebAssembly as their functionality. And they do also support the Zephyr RTOS. I saw that on their docs as well. But their, you could say, a strategy here is Docker on a diet. That's what they call it. And you can write a Docker Compose compatible container, but deploy it to an MCU. So that's pretty interesting and revolutionary, quite honestly. So that's one that you might want to check out over on the MCU class devices. Blues. Now, Blues, I would tend to think of as a connectivity company because they build what's called the Note Card. And the Note Card comes in cellular flavors, Wi-Fi flavors, even LoRa as well. And they offer turnkey connectivity no matter what region of the world you're in. And they also have the Note Hub, where data is routed from Blues to other cloud services and service providers. But they do offer some turnkey products as well, such as the Swan. And the Swan offers OTA firmware upgrades through their DFU system. So that's another one where you might get kind of an all-in-one system if that's something you're looking for. Finally, the last one on our list is another brand new one, Thistle. And Thistle is really interesting from the perspective of offering both MCU and CPU class support. They have these runners, these clients, and they've got one available for Zephyr and one for Linux. So this might be an interesting way for you to mix and match your fleet of devices. They have an emphasis on security, secure boot, verified boot, trusted boot, as well as the secure OTA. And they do have Yocto layers as well. So you can do artifact updates as well as full A and B partitioning updates and fallback if you're over in the Linux world. So definitely check that one out as well. All right, that does it for our tour. We took a look at a lot of options in a very short amount of time. But we, have focused on how to go about updating either an application or an entire device. And some of them focus more on security. Some of them focus on the application update only. Some of them focus on the full OS update. You basically need to pick whatever is best for your particular situation. But no matter what, any of these should give you the ability to change the workload or the task that your device is performing, because that's what we care about. The reason that matters is because, like we were talking about earlier, we want to be able to collect data from the end location that the device is located in. That's where the most representative data is going to be found. You want to be able to reach a point with any of these platforms that you can switch between collecting data and uploading it into your data set, and then changing back to running inference with a newly deployed model sent via OTA. Again, you'll need connectivity, which I realize is not always a given when it comes to Edge AI, but if you've got that, then you should be able to choose from one of these platforms, or like I said, there's others out there, but you want to be able to flip back and forth between collection and inferencing in order to close that loop that I showed earlier. So that will do it for now. I realize this was just a high-level, quick introduction on the topic or concept of MLOps, but definitely just reach out to us if you have any questions or there's other things that I should keep in mind when I consider doing these kinds of sessions. For now, though, let's see if we've got any questions. Feel free to pop them into the chat, and we'll do our best to get them answered live here. Thanks a lot. Have a good one.